Hi, this is Mr. McGovern, and in this video on projectile motions we're going to do our first calculations. So I'm going to go through the steps and give you an example of what to do. So here's a situation where I have a poorly drawn cliff with a ball at the top which is rolling 25 meters a second to the left, and it rolls off the cliff. So the question is, what distance from the bottom of the cliff does it land? Right, the steps we're going to go through is we're going to draw motion maps first for the horizontal and the vertical. We're going to come up with a table of values for the horizontal and vertical, solve some calculations for time. The time we find in the vertical is the same in the horizontal as well, and solve the horizontal distance. It looks a lot. Each step you'll find as you follow along makes a lot of sense. You should be able to do and understand each step. It's just about putting them all together. Makes more sense when we've got the numbers as well. So let's just go through one at a time. Alright, motion map. So the motion map, the reason we draw motion maps is it reminds us to treat the horizontal and the vertical motion differently or separately. The other thing is it sets up a coordinate system. The coordinate system means where's our zero and which direction are we choosing to be positive. Very, very important for most calculations in physics, is choosing our direction to be positive and being consistent right the way through your calculation with that. So remember, we can split this into horizontal and vertical. So here is a horizontal motion map. I've chosen positive to be to the left because the ball's moving to the left. That makes sense to me. Its horizontal motion in the first 3 videos we discovered was constant. It goes a steady speed horizontally each split second. So I've got those V's on there, the same size. And vertical motion, it's moving downwards, so it makes sense. It's moving downwards. Its acceleration is downwards to make positive in the downwards direction for this question. The velocity, its vertical motion, we discovered in the first 3 videos, increases, and that's due to it accelerating, and that's also pointing down. Okay, so now we've got an idea that we have horizontal is a constant speed, and vertical is acceleration. So I build a table like this, even when I'm solving problems at the end of your exam. I'd still build this table, so I know to keep the horizontal motion and the vertical motion separate. I also write down constant velocity under horizontal motion so I remember, and acceleration under vertical motion so I remember. Then I put everything I know about the horizontal and vertical. Now that I've got a table, it's easier to separate the two and not get them confused, which is what I find most students do. So horizontally, its velocity is 25 meters a second. We don't know how much time it's moving for. We don't know how much distance it goes for. But eventually that's what we want to find out. It's horizontal distance. How far from the cliff horizontally did the ball go? Vertical, what do we know? Acceleration is positive 9.8. It's positive because we've chosen downwards to be positive. The initial vertical velocity is 0. It doesn't have any vertical velocity to start with. It's only going horizontally. We don't know its final velocity. We don't know how much time it's in the air for. But we know the distance, the vertical distance it's moving is 20 meters. Okay. Using this information, the vertical information, because I've got the most information on that side, I'm going to do a calculation for time. How much time does it take to get to the bottom? So I've moved all my information up there, and I look for an equation of motion that has the right amount of variables in it. And so quickly I found this one here because I've got distance, I've got initial velocity, I have acceleration, and I want to find time. The cool thing about this equation, it's really useful when you have an initial velocity of 0 because it simplifies like that really quickly. I need to find time, so I need to rearrange it. Now I've done this in one step, but if you want to make sure you understand everything, you'd stop and you'd do this in a couple of steps yourself to make sure you can do it. That's time. Put all my numbers in. 2 times 20 meters over 9.8. Find the square root of that, and that gives me 2 seconds that the ball is in the air for. That 2 seconds I've now put in my vertical motion, but you've also noticed I've put it in my horizontal motion as well. T is important. It is the value that links the horizontal and the vertical sides of this table. It's the only one that is the same in both, because it makes sense. The time it takes to fall down vertically is also the time it travels horizontally for. It's the same ball, the same time. Once we've got that value for time, we've now got enough information to use a simple formula to work out the distance in the horizontal motion. Because horizontal, that left side of the table is going at a constant velocity, we can use the constant velocity equation. Distance is velocity times time, which we've got 25 meters a second in 2 seconds, equals 50 meters. What does that mean? It means it's moved horizontally 50 meters by the time it hits the ground.